Hello once again. Major progress has been made on our cabinet, and I still need to clean these wheels. They're kind of gooked up. I might just throw them in the evapor rust and let them sit for a couple of days. I don't know what I'm going to do. I might clean them up with lacquer thinner. I don't know. But I do have some progress on the wheel front. What we're going to do is I have the wood cut. These are going to be our new wheel bases. This is this one's going to go on the bottom of the cabinet. And then this thing actually, it'll be like this. It'll be like this with, well, let me see. It'll be like this. Come on, baby. Like so, okay, on the bottom of the cabinet. Then you'll have your cabinet wood sitting on top of here. And then this one will go inside the cabinet on the other side. So we're going to have two blocks of wood, brand new wood, holding the entire mechanism together. I have the long bolts that go all the way through with the lock washers and the flat washers and all that. And we're going to have a nice sturdy set of wheels down there. And because the wood is kind of weak, the wood is too weak, and I just don't want to mess with it in the future. Have to get back in there. Wish I had done something about it when I had the chance. Now's the time to do it. We'll go ahead and paint these things, give them a good coating of primer, and on top and bottom. Then we'll put them all in, and then we'll paint them with the final paint that we're going to be using, to whatever color. So there has been a lot of progress, and we've got a lot of things repaired. Still haven't got around to the edging, but we will get to that. That's kind of minor, actually. I want to get the main stuff done. Let's go over, work on the chassis now. I've been checking out these resistors, and believe it or not, so far everything checks out great, and all within tolerance. But you know, I ran into a couple of things I thought I'd point out to you if you're ever working on a very old chassis like this. Or what is this thing, about 50 years old, something like that, 55? I don't know. I can't. It's a lot. Okay. You know, whenever we work on electronics, we're always saying, well, you know, you need to keep the wires up against the chassis, you know, to prevent, and receivers, you know, and transmitters to prevent hum and all interference and noise and all that. That's correct. However, when you're working, it's been my experience that when you're working on old electronics, it's not a good idea to have cloth-covered wire. Let me see. See this example right down here in the corner? You should get a little focus here. Okay, see this cloth covered wire? This thing was right up against the chassis right here. Let me get a little more light down here. There we go. Now we can see. See where that wire was pressing up against that chassis? You see that black mark right there? It's been my experience. You do what you want, but it's been my experience whenever you have cloth covered wires to get them away from the chassis. I've had wires where the insulation was worn all the way through the wire and touching the chassis and shorting out. So I got really gun shy over the years, and I try to at least provide some kind of space between the chassis and a cloth covered wire. Here's another example right here where it comes out of the power, yeah, this is the power, yeah, it comes out of the power transformer right there, and it comes out of here, winds on around, and goes over here actually to a ground, I guess. Anyway, suppose that was not, we'll pretend that was not a ground. See where that cloth cover wire is laying up against that transformer? Always a good idea to try to get something down in there and create a little bit of space. Doesn't take much. You don't have to put the gorilla touch on it, you know, just enough. Give yourself a little space. Don't let those wires lay up like that. Now these kind of wires are plastic coated, things like that, not a problem. The only problem I've ever had is these cloth covered wires. I hate seeing these things up there like that. I want to create a little bit of space here against there. Now, one other thing. When I sprayed the top side of the chassis with the brake cleaner, and I used the evapor rust, some of it of course went down between the tube sockets, and it loosened up some of the flux that had been put on at the factory. Let me get over here where we get a little better view, get our light going. Sorry for the movement of the camera around there, but I want you to see what I'm talking about. These, back in the factory, they used tons of rust. Even later on in the 60s, I mean, not tons of rust, they used tons of flux. But anyway, they used a lot of flux when they soldered their joints, even in the 1960s. And what happened was that spray I used and the evaporust loosened it all up, and it made it all kind of runny and everything on here. You have to get down and clean that. I don't know why they use so much flux at the factory. It just astonishes me to this day. You only need just a tiny bit. And especially when the stuff is new and the wiring's new and the contacts are new and everything is new, it's easy to solder. Anyway, they would wrap it around and around and go ahead and, you know, bathe it in the flux that would come out of the solder. I think they used much thicker solder than we have today. Anyway, you notice how I've got it nice and clean now, as best I can. Now, it's not spotless, but I got it as clean as I can in between each of the terminals on the bottom of the tube sockets. Each one, you do your best, you know. Just do your best. Here's another one here. And the way I did that was I took a little acid brush, my standard old acid brush that I pretty much use for everything. This little short stubby one that I cut down to bristles, you know. And then you just kind of take it and get in there and sweep it toward the center. Get it toward, first you spray it. You spray it with contact cleaner. I like to use this QD electronic contact cleaner. It's a lot cheaper. You get it at Walmart. And you go ahead and spray your socket down, and then go ahead and get it brushed while it's still wet. Then give it another spray, and it'll pretty much wash everything down the center and on out, or off to the sides and on out, depending on the type of tube socket you have. Keep those babies clean. But fortunately, everything's checking out pretty good so far. Just keep on going. I'm doing resistors today. I just spent the last hour, maybe hour and a half, finding every one of these electrolytics that has a check mark in it. I found first I found, you know, the electrolytics on the parts list. And then I went to the schematic and found them and marked them with yellow marker. And I wrote the value of the electrolytic next to the capacitor on the schematic. For instance, this is a 50 microfarad rated at 6 volts. It says lytic. So what it looked like when I got done, I did that for every single electrolytic. I didn't do it for the rest, but just the electrolytics. And when I got done, I had a bunch of yellow marks everywhere, all highlighted. Easier to find this way. These things can just make you cross-eyed, okay? And the rest of them were over here on this part of the schematic over here. All highlighted, ready to go. All the tube pins, fortunately, are already numbered, so I don't have to go through and do all that, as you can see right there. Very nice of them to do that. Here's something else for you new folks that, you know, you're checking out a small chassis. It doesn't have to be anything as large as this. This is giving me a hassle, actually. They've replaced a lot of electrolytic capacitors in here with wrong values. I mean, they're okay to work in the chassis, but they don't match up with my parts listing over here, so I'm having to really skull brain this thing. But anyway, we'll figure that out. What we have here is we have two 12AX7 tube sockets, one there and one there. And mounted to the center pin on the tube socket is a little circuit board of some sort. A little terminal board is what they've done. Let me see if I can, maybe you can see it better if I turn this away and just, yeah. In the center of the tube is a pin that sticks up there. So you see that silver pin right there going vertically right there in the center. It goes up and it holds this terminal board on here. And some of the things that are soldered to the terminal board go back down to the tube pins. So what we have is two different channels, A and B. So they're going to be identical. And they are identical. You know, every resistor is the same, every capacitor is the same. Even the ones that have been replaced, which are these two electrolytics, are the same. So take a look at this. You know, what I have here on this one here is a nice shiny, get down there nice and close. We have a nice shiny resistor. Nice, looks almost brand new. Over here, the same resistor. Look how dull and terrible looking that thing is. Should look like this at a minimum. That doesn't mean this resistor is good. I'm just telling you right away that's something you should zero in on. When you have two resistors, you know, that are supposed to be doing the same function side by side on two different terminals for two different channels, they should both look very nice or very bad, you know. In this case, this one's very bad. Let's take a, and it's very bad in my mind. Let's take a close look at it. Watch where I'm putting my probe here. It is, ladies and gentlemen, it is broken. Look at there. Let me get over here where you can really see well. It's kind of tough. I'm about run out of room on my light. There you go. See that cracked? Look at there. That is a broken resistor. And the only reason I noticed that, let's get that thing right on out of there. The only reason I noticed that was because it was a different color and it was just basically in different condition from the one on the other channel. Okay? We will be replacing that resistor. You know, that was the, you just got to look around. You mean nice shiny one? Nice crappy one? Alert time. Take a very close look at it. If there's any question in your mind, even if it weren't broken, I was going to change that anyway. It just doesn't look right. I told you early on, if it looks at me bad, it's out of there. Now here's another little ditty. Now this resistor is supposed to be 47 ohms. And as you can see, that third band there is burnt black right there. And it's hooked to this rectifier, this selenium rectifier. You know, believe it or not, it ohms out at 48.9 ohms, which is not bad. But you see, when you see something like that, you don't know if that's burn, that's age, or what is it. You don't know. So what you need to do, let me get down there closer. It looks like a burn to me. I don't know. That one there is going out. We're going to get rid of it. You know, we can't. I don't want to take the chance. Not over a resistor that costs what, 10 cents, 8 cents, something like that. Get it out of there now. That's the type of things you look at. Little tiny things that should be catching your eye. And the more you work on these things, the easier it is to spot that stuff. Well, I'm beginning to get cross-eyed looking at all this stuff and comparing it to what I see here and trying to find it on a schematic. And, you know, when you start getting tired, you're starting to get cross-eyed, you know, give it a break. Get away from it, because if you don't, that's when you make mistakes. I probably won't even come back to this until tomorrow. But, you know, one more thing, getting back to this capacitor right here. Again, what we have is a mistake made by a technician. Instead of disconnecting the terminal, he replaced a capacitor inside this electrolytic can. Instead of disconnecting the terminal and reattaching it to another terminal out here somewhere, he just went ahead and soldered the positive end right to the existing terminal of the capacitor. You know, you can't do that. Don't do things like that. That's very, very bad. I'll tell you why I know this. The very first radio I ever worked on, I did that. I said, well, I'll just solder new capacitors on the connectors, on the existing connectors on the bottom of the electrolytic filter cans. I'll tell you what, it did not work, and I didn't know what was going on. You know, I had no idea at that time. So I got on the antique radio forum, and, you know, a couple of guys jumped in and, you know, tried to help me out and everything, and Kurt Reed was one of them. And then finally I said, well, I went ahead and soldered these on like this, and I showed them a picture. I posted a picture to the forum, and they went, oh, John, don't do that. Don't solder directly to those terminals unless the electrolytic can has been removed, or the connector has been somehow, or the terminal rather, has been somehow isolated from the can. Don't just solder directly to the terminal. You got a bad capacitor on the inside here that's now connected to this one here, and and if that other one is shorted on the inside, guess what? You're going to cause this one not act very well at all, and it might even take this one out with it. So don't do that, guys. Use a terminal strip or separate that terminal somehow and get it up and isolate it and keep it away from everything else. For those of you who maybe just recently started tuning into my channel, and you've never seen any of the previous videos where I, restored radios and things of that nature, I thought I'd show you, or maybe this is your first time on, tuning in. I don't know. I thought I'd show you how I go about changing out a bad resistor or a bad capacitor. I do it the same way for both. And if I add a wire, to make a wire longer, I do the same thing to both ends of the wire that I'll be doing here with the resistor that I have just removed. Now, first thing I did was take the cutters and got down real close to the resistor and cut it out close to the body of the resistor. See how close it is? That's how close I cut it. And the other end wasn't any problem. It was just all busted. Remember, that was that busted one. That's what they look like when they crack, by the way. They bust all the pieces. See if I can get a better focus on that for y'all. Probably not. No, guess not. It just doesn't want to cooperate, I guess. Anyway, you can pretty much see it's busted. Once you snip it out, you got yourself a little stub. And in this case, I got my stub right here. And I have my stub right here. So what I do next, I take my little, my little flat bill, duck bill pliers. I have no teeth in them. Try to get a pair of these guys. They're almost indispensable for working on small components in a chassis. It doesn't matter what chassis it is. Then I take my duck bill and I move the stub around to where it'll be more advantageous for me to put the resistor back in. And previously it was like really flat. I want it up and toward the center here. And once I get that done, I may have to do a little more adjusting on it, but as you can see, I got it pretty much pointed toward the center, and this one here pretty much pointed toward the center. And I'll probably do just a little bit more adjusting, then we'll go to the next step. The next step is to take an alcohol brush, put it down in some 91% alcohol. That's what I always use. You could use 70%, it doesn't matter. I like the 91%. Then go ahead and clean the area real good that you're going to be soldering. In particular, the stubs that you're going to be soldering to. See that one right over there, and that one right there. We're going to give that a good clean underneath and everything. Give underneath those stubs. Give them a good cleaning. Then you can just take you let it air dry or blow some air on it. Some of that expensive air in the can. Amazing. I never thought someday I'd pay for bottled water and canned air. Alright, now we'll just let it dry a little while longer and we'll move on to the next step. The next step is to take your resistor. Now this resistor that I took out is a 5600K. I'm sorry, 5600 ohm resistor, 5,600 ohms. Now I don't have any 5.6K, all I have is 5.1, which puts me within the 10% tolerance. So we're going to be replacing it with this. And we're going to position this thing between the two stubs until we get about equal distance from each. And we kind of get an idea. Now keep in mind there's the one stub on the left. It's a little bit hard to see with that black. That's one stub, that's the other stub over here. I'm going to kind of position, eyeball it in the middle. Let me see, it's right there. Right there. Kind of eyeball it in the middle. Take your time on this, there's never any rush. And I can see I don't have a whole lot of clearance, but I can do this. Maybe a 1/4 of an inch on each side, maybe not quite that. Alright, now let's go to the next step. To help me along, I went ahead and took my needle nose pliers, because you can see, it can go from like really, really tiny all the way back to really, really big, and you can kind of position it exactly about where that center point would be between those two stubs. Let me find it. It's hard to find in the camera here. Let me get it positioned. Right there. There we go. Right about between the two. So that'd be about right there. About right there with the position on the needle nose. Now I take it and I just bend it. Let me show you here. I'll bend it and come back. And that shows you just about where you're going to be doing your bend to make a coil. I have a jeweler's screwdriver that's really, really tiny that I use for this. You place the resistor right where that bend was. And it's not going to be 100% accurate, keep in mind. And now I'm going to start, you keep the two close together. Now I start coiling that wire around the shaft of that screwdriver. Let me finish that. And there it is. Now we'll remove the screwdriver and put it in from the opposite direction. And just like that, by holding the resistor and holding the jeweler's screwdriver, I can maneuver it left and right and straighten it out fairly straight with the resistor. Let's do the same thing to the other side. When you get done, you have something that looks right about like that. Now you can bend these things, a little bit down, a little bit up. You can actually bend them just about any way you want, as long as you do it, as far away from the body of the resistor as you can. You don't want to be cracking this one like that other one was cracked. Let's see if I can't position it on those two stubs now. It'll hold itself in place while I solder. And there it is, positioned over both stubs. The coil on this end, and the coil on that end. And all I have to do, and it holds itself. And you can, like I said, you can bend those coils in just about any direction. Now sometimes you have to play a little bit with the stub, maybe raise it up a little higher, maybe raise this one down a little lower. It depends, just kind of take your time, work it, work it, work it. You don't want to have any strain on this. That's how I do it. Now I'll go ahead and solder those babies, both ends in place, and we'll see how she looks. And this is what I'll be doing for all the components, capacitors, whatever. And there we are. We'll go ahead and clean this up with alcohol after we're done, get all the flux and crap off of there. Now the primary reason I do this is not to be fancy or anything like that. The primary reason I do this is I don't want to disturb the solder joint on the terminals. When you're dealing with old sockets, you start sucking solder off of there, you can break so many terminals on sockets, it's unbelievable. I broke about 5 or 6 before I finally wised up. Alright, now this is a replaced electrolytic. This is a replaced electrolytic. And they just took it and wrapped it around there, but I'm still going to go ahead and probably just use the coil method on those. I really don't want to disturb that solder joint any more than it's already been disturbed by whoever put these in. Well, that's going to be it for this, I think, episode. Yeah, it's just, from here on out, it's just a matter of measuring and replacing what's bad. Pretty boring stuff when you think about it. Until next time, this is John.